Hello, welcome to TGM's tutorials. In this tutorial we shall look at the topic Cramer's rule. This will be lesson 8. Let's look at the definition of Cramer's rule. If we let this system of linear equations be a system of three linear equations in three variables, and if the coefficient matrix A, this coefficient matrix, we are just getting the coefficients of these variables. For example, x, the coefficient of x here is 1 1, so we're just getting these coefficients and write them in a matrix form. These are the coefficients. If we take out these coefficients, they will form this matrix A. If this coefficient matrix A is non-singular, by non-singular we mean it has an inverse, and if it has an inverse, then the determinant of this matrix exists. Then the solution of the system is given by the value of x is equal to the determinant of b1, b2, b3, a12, a22, a32, a13, a23, a33 over the determinant of a. Here I want you to notice something. On the value of x, on the determinant, we have this column with a different set of entries, b1, b2, b3. And where are we getting these entries? It's from here, the results here. So we are getting b1, b2, b3 from this part. Okay, and the value of y will be equal to, now here again I want you to notice something. To get the value of x, we are removing these entries in the first column, and replacing them with these entries. And to get the value of y, we are removing entries in the second column and replace them with b1, b2, b3. And to get the value of z, we are replacing entries in the third column with b1, b2, b3, whilst maintaining the rest of the entries. After finding the determinant of this matrix, then we divide by the determinant of A. Of course, we know how to find the determinant of a matrix, a 3 by 3 matrix. Okay, and this method is what we are calling Cramer's rule. Let's look at this activity. We are going to use Cramer's rule to solve the following system of equations. In the first equation, we have x minus 1, which is equal to x minus y, which is equal to 1, 2x plus y plus 3z, which is equal to negative 3, negative 2x minus z, which is equal to 0. We are going to take out the coefficients of these variables and write them in a matrix form. So in the first equation, we have 1 for x as the coefficient of x, negative 1 as the coefficient of this negative 1. Here you've noticed that we don't have z, so therefore the coefficient of z is equal to 0. We also have 2 as the coefficient of x, and 1 here the coefficient of y, 3 the coefficient of z, negative 2 the coefficient of x. Here we don't have y, so the coefficient of y is 0. That is the 0 we are getting here, and negative 1 as the coefficient of z. So we are going to find the determinant of this matrix, the coefficient matrix, as the first step. And if you do the calculations, you find that the determinant of this matrix will give us a 3. Okay, if you are not sure on how to find the determinant, we are going to do it quickly here. So we have 1. We are going to consider the first row. We have 1 multiplied by this matrix 1, 3, 0, -1, then minus -1, then multiplied by the matrix 2, 3, -2, and -1, then plus, you know that everything multiplied by 0 should give us a 0. So we are going to have 1 multiplied by -1 multiplied by 1, that will give us -1, and 0 multiplied by 3, that will be a 0. Negative multiplied by -1, that should give us +1, and -1 multiplied by 2, that will give us -2, minus -2 multiplied by 3, that will give us -6. This will give us -1 plus, that will be -2, -2, this will be plus 6, that will give us -1 plus, that should give us +4. -1 plus 4, that should give us 3. Therefore the determinant of this matrix is equal to 3. Okay, now you know how to find the determinant of that matrix. After finding the determinant of this matrix, we shall continue to the next step. The next step is to find the adjoint of that matrix. Now before we find the adjoint, we should move step by step. We shall first find the minus. We shall first find the there is no need of finding the adjoint. We shall just proceed to replacing. For the value of x, where we have the first column, we replace by these entries. Okay, now in x here, we are going to replace this by these entries, and in y shall replace by that, and in z by that, and we have determinant of that. So here we have determinant. We have replaced in the first column we have 1, 2, and -2 have replaced by 1, -3, 0, and the determinant of this matrix is equal to 2 divided by the determinant of A, which is 3, and we are going to have 2/3. For y we have replaced here with 1, -3, and 0. The determinant of this matrix is given us a -1 divided by 3, and we have y is equal to -1/3. For z we have replaced again with 1, -3, and 0, and the determinant of this matrix is giving us a -4. Divided by 3, we are getting z is equal to -4/3, and you should get these answers as the solutions for this system of linear equations. Okay, thank you very much for watching this video. If you'd like to watch more videos from this channel, just click the subscription button below and more videos will come your way. Thank you.